Hi, class. This is exercise explanation 2.1. So we're supposed to write the electronic configuration of a neutral atom with a S and P electrons only. Okay, so they want to do beryllium. So beryllium is Be. So I need to look on this periodic table, and beryllium is going to be this one right here. Okay, and so that is atomic number 4. So that means we're going to have in a neutral atom 4 electrons. So, so if I have Be that has atomic number 4, so I'm going to fill my S, 1s, or my orbitals in this manner: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. That's kind of the way it goes. You can get this layout of the book. So you're always going to fill 1s first, and then you're going to go into 2s, and then 2p, and then 3s, 3p, so forth. And so the 1s, we have 4 electrons. So we're going to put 2 electrons in it. And then we have 2 electrons left, and then we're going to put 2 in that. So the P is not going to be used, so we could actually scratch those out. So the electron configuration for beryllium is 1s2, 2s2. So what that tells us is a little bit more than just numbers. It tells us the location of the electrons, how far away they are. So if it's in the first energy level, it'll be circling around nearest to the nuclei. Second energy level will be a little bit further away from the nuclei. Or from the nucleus, I guess. And so, so this is the 1 energy level and the 2 energy level. The S tells us it's going to be in shape of a sphere. So these electrons in the 1s will be kind of traveling around here in the shape of a sphere. And then the 2s2, there'll be 2 electrons that are further out that are traveling around in the shape of a sphere. If we were able to get the p orbital in there, it would be the same distance away, but they would be shaped as a figure 8 in 3 axes. So the x, y, and the z. So there would be 2 in each one of those, and so forth. So this one's going to just be the 1s and the 2s shells, and then the orbital subshells. Okay, so that's the best way to do that one. Now let's do a little bit a different one. Let's do fluorine. And that will have 9 atomic number. For those, there's 9 protons, 9 electrons. So we're going to do the 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Okay, so we have 9 to fill. So we'll do 1s in the 2, second 2 in the 1s subshell, and 2 in here. And that'll give us a p and 5. That's 9. Okay, so 1s2, 2s2, 2p5. So that's total 9. So we're done. Okay. And so the way this one we'll figure out 3-dimensionally. So here's the nucleus. So there'll be in the first energy level in the shape of a sphere, and this is subshell is a sphere. And so the electrons will be orbiting around in that shape. So that's the 1s2, and then there'll be 2 electrons orbiting around in the shape of a sphere that are further out. So this is the 2s2, and then there's some in the p5. So that we're going to do a figure 8. So there'll be 2 electrons running around there, here, here. So it'll be 2 in the one, 2 in another, and 2 in the third one. So if another way we can look at this is we can do 1s, and we can do a diagram, so we can do it up and down. So that's their opposite spins. 2s, and that's going to be up and down for electrons. And then 2 is px will be up, 2py, 2pz. So we'll go up for one of those, and then we can start doubling them up. So it'll be 2px, py, and then pz's. All right, so that's how you're going to do this. Let us know if you have any questions.